Okay, we're in the next section dealing with elastic potential energy. You've already been exposed a little bit with that Walter Fendt demonstration of spring potential energy or elastic potential energy. So now we're going to continue elastic potential energy. As you know, the energy stored in a stretched or compressed spring or some other elastic material is called elastic potential energy, PE sub S. The figure shows a ball being projected from a spring-loaded toy gun. The spring is initially compressed a distance x. When the gun is fired, the compressed spring does work on the ball and imparts kinetic energy to it. Okay, let's apply the law of conservation of let's apply the law of conservation of energy and include both gravitational and spring potential energy. If non-conservative forces like friction are present, then the change in mechanical energy must equal the work done by the non-conservative forces. So keep in mind that we need to include rotational kinetic energy in both of these equations for systems involving torques. Okay, take a look at the figure. Take a look at this figure. A block of mass m slides on a frictionless horizontal surface with constant velocity v sub I. The total energy of the system is the kinetic energy of the block. For our discussion, let's assume the spring is very light, an ideal spring, and so has negligible kinetic energy. As the block collides with the spring is compressed and it exerts a force to the left on the block. Now the block has kinetic energy 1/2 mv squared, where v is less than v initial. And the spring has potential energy 1/2 kx squared. When the block stops for an instant at the point of maximum compression, the kinetic energy is 0. This is very much what we were demonstrating on the Walter Fendt video. Because the spring force is conservative and because there are no external forces that can do work on the system, the total mechanical energy of the system consisting of the block and spring remains constant. Energy is transformed from the kinetic energy of the block to the potential energy stored in the spring, just as we saw in the up and down motion of the Walter Fendt video. As the spring expands, the block moves in the opposite direction and regains all its initial kinetic energy. Okay, and the next, let's see, okay, there is one more slide. Here's a photo of an archer. When she pulls back on a bowstring, elastic potential energy is stored in both the bent bow and stretched bowstring. When the archer releases the arrow, the potential energy stored in the system is transformed into the kinetic energy of the arrow. Crossbows and slingshots work the same way. Okay, let's stop it here. Stop the share and stop recording.